Here we are in section 3.3 with the answers 1 through 5. Three types of horses are in a local ranch. The number of Arabians, okay, look at that. We're going to have Arabians is 8 more than twice the number of quarter horses. Okay, quarter horses right there. The number of Clydesdales, look at that. 50 more than the number of quarter horses. Q. There are a total of 282. So we've got Arabians, Clydesdales, and quarter horses, and that adds up to 282. There's our base equation right there. Now if we look at some of the other things that talk about it, Arabians is going to equal 8 more than twice the number of quarter horses. So this right here is going to be 8 more than twice the number of quarter horses. And the number of Clydesdales, so C, is going to equal 50 more than the number of quarter horses. 50 plus Q, or Q plus 50. So there we have our equation. We're in happy math land right now. We have our equation. The Arabians plus the Clydesdales plus the quarter horses has to add up to 282. So we keep going now. 2Q, 3Q, 4Q. 4Q plus 58 equals 282. Means 4Q, subtract 58 from both sides, and we get 224. Divide both sides by 4, and we get the number of quarter horses is 56. Woohoo! There we go. Quarter horses is 56, so that means the Clydesdales, 50 more than that. Clydesdales is going to have to be 106. Clydesdales. And the Arabians is going to be, we take twice that as 112 plus 8 is 120. 120 Arabian horses. Good. Number 2. What is the radius of a cone? Oh, we're in a cone. We better find out what formula we're looking. Lateral surface area. So we've got to find the LSA formula. LSA equals pi r L. That's it. So we could look back in section 2.2, I think, has all those formulas in it. And so we look back and we find this formula right here. This is the slant height. That's the radius. So it has a lateral surface area, 197.92 square inches, its area, and a slant height of 9 inches. So we're looking for the radius. Leave the r there, and then we have a 9. In order to get r by itself, we need to divide off the pi and the 9. If we divide off the pi and the 9, then we have r, and that is equal to, hey, look at that, 7. Don't forget the inches. Number 3, solve and graph the solution of this. Ooh. We've got x's on both sides. I'm going to get rid of those fractions. Times everything by the least common denominator. That's a 2. 6x minus 2 greater than 5x plus 18. Good. Subtract 5x from both sides and add 2. X is greater than 20. So on the graph, it looks like this. There's 0, there's 20, and we have to be bigger than 20. So it's all these numbers up here. And there's our open circle because we're not equal to it. There you go. There's the solution and the graph. And recall that some will put like a little cute dressing on it to make it look nice. Could be 2 dots in here as well. Alrighty. Number 4. Original price is $392.50. $392.50. And the tax is 6%. So that's 6% of that original number, and tax is adding it. So we're going to times this by 0.06, and then we're going to add it to $392.50. And that should equal the final price. Punch that in the calculator, and we get $416.05. Don't forget to round to the nearest penny. Alrighty, number 5, original price. We don't know this one, but we know that the tax, which is going to be a plus, is 7%. That's 7% of something we don't know. We better put a p there. This is what variables are for, and algebra will help us do. You have 0.07p, and that gets added onto, because it's a tax, to the original price. That's what's so tricky about these type of problems. These two happen twice. Just like over here, you'll notice that we wrote the 392.50 two different times. One had to times the 0.06, and then one was the base price that had that tax added onto it. So we get 73.90. We can combine these like terms. Remember, there's a 1 in front of that, so we get 1.07 p equals 73.90. And then divide by 1.07, divide by 1.07, and we get p equals $69.07. $69.07 was the original price. Good.